Thank you, everybody, for joining us here today. My name is Aaron Kobernick. I'm with ByteSpeed. I'm our RUCKUS solution specialist. Today, we have Rich Nedwick from RUCKUS, who will be presenting on how RUCKUS AI can help your IT teams reduce burnout and turnover. Hi, Rich. You feel free to introduce yourself and get started.
Thanks so much, Aaron. Thanks for the opportunity. Let me get my screen up here for you guys to all see it. There we go. Hopefully we're good.
Yep, looks good. Thank you.
Thank you for having me, and welcome everyone. My name is Rich Nedwick. I'm the Senior Director of Education at CommScope and RUCKUS, you know, our dog, and happy to be here with our friends and one of our best partners in ByteSpeed. And today, what I want to talk about is actually some exciting innovation coming from RUCKUS to enable smarter network visibility with AI and machine learning. And the benefit in particular that I know is going to resonate with many, based on conversations I've been having the last few months, is reducing IT workload while allowing you to create better networks. And so, you know, whether you're hearing about OpenAI, ChatGPT, et cetera, it's a very, very popular, frothy topic right now, as it regards to, let's say, students coming up with their assignments, or teachers grading their assignments, or even instructors coming up with lesson plans. There's applications coming left and right. But one of the more interesting ones is, what can we do within IT to leverage AI to make our jobs easier and better? And that's what we're going to cover today. All right, so let's get into this. Again, if you're not familiar with CommScope RUCKUS, our vision is to push the boundaries of technologies to create the most advanced networks to help you connect students to their world. And what I hope you're going to see is that the instance of this is pushing the bounds of technology with AI to enhance what networks can do, and with what anyone on an IT staff can do with it. And I'm excited to share that with you. So just bear with me, and we're going to get to it in a few minutes. But before that, I want to step back and say, look, as the head of our education segment, I speak to customers worldwide in higher education. And what we've done is try to articulate sort of a roadmap vision of where we can help you get to. And we know that one of the most important aspects of higher ed right now is, how do we get the kids, you know, attract them onto campus, retain them on campus by getting them engaged digitally in campus life so they can lead to a successful outcome for them. And there's a number of ways to do that. Many institutions believe they need to pivot to a more student-centered campus. The question, of course, is, how do I do that? And what's IT's role in that? And number one, we believe first step of that roadmap is just to create a connected campus. That could be any number of different technologies: wired Ethernet, Wi-Fi, cellular, all interconnected with copper and fiber, structured cabling infrastructure. So that's just a connected campus. And then, how do we create a smart campus? Meaning, how do I know what's going on my network and on my campus users? And I can leverage things like IoT to give me contextual information of what's going on in my network right now, and who's using it and how much, and, you know, are my assets being utilized, and so on. And then leveraging that data with AI ML analytics to give me more insight so I can operate more efficiently and offer new services. Ultimately, we want to leverage all of that connectivity and insight to deliver a more personal campus experience. And that could be around new services that you're going to offer, about, like, you know, wait times in the cafeteria, or it could be supporting esports and gaming wherever I want to play, on whatever device I want to play, you name it. So that's sort of our 1, 2, 3 approach. So ubiquitous connectivity from cable to cloud, and then insightful connectivity for new services and savings, and ultimately delivering connectivity for student-centric experiences. So today we're going to talk more on that middle side, on that AI ML. So, you know, I just mentioned a number of different ways that campus users can connect. And one of the challenges that I see often is that these networks are now getting too complex for us mere mortals to manage effectively, as IT is being tasked not just to make the Wi-Fi work, not just to make, you know, the wired Ethernet port in my residence work, but now, you know, if I'm trying to make a phone call, I'm going to call IT if I can't make a phone call. And, you know, my Google speaker needs to connect, and, you know, what's my IoT support strategy, and can I get private wireless to run in here so you know, I can make that work? So it's all different kinds of different technologies. And so how do we radically simplify this to make it more manageable while retaining insight and control? And that's what we're going to talk about today, because honestly, the cost of all of this, the cost of this challenge, is in the network troubleshooting that's escalating, right? And so the cost of this, whether it's time, whether it's money, it's too high, right? So we don't have more budget. In fact, if you have a fixed budget, you're facing inflationary costs where basically your budget is cut if it isn't being raised. And the time that we're spending troubleshooting these increasingly complex networks is cutting into the time that we could be spending on, aspects of your 5-year strategic plan for your campus, for example. Now, if I break it down a little bit more, network management for normal humans, you can see, about 40% of network pros have said that they're spending too much time troubleshooting. I wouldn't be surprised if that number was probably higher. And then of these network professionals surveyed, 38% said, look, it's really hard to get ahead of things. I'm always reacting, I'm always responding to issues, and I'd really like to get ahead of it, but it's hard to do that. And if I had to pick one, I'd say my wireless network is my top challenge, right? And so wireless is tricky, and we've been hearing that for years and years, and it continues to be. And so as we move to more and more wireless campus, then, without help, things are just going to get harder and harder going forward. Luckily, things are continuing to evolve. And if we look at the era of networking that we're in and where we've come from, you can see that, back in the 80s, we started out with LAN networks that migrated in the 90s to TCP/IP-based internet-based networks. And come 2000, we started getting into the wireless LAN era. And personally, that's where I got involved. In the year 2000, I started at Simple Technologies, which was one of the founding members of the Wi-Fi Alliance. And, we had frequency hopping networks using .11b, right? And it was really just hotspot access, and it was kind of convenient access. But it caught on quickly, and we started to see the need for centralized controllers, which actually came out of Symbol as well. And then ultimately that became decentralized, control plane in every access point. And then ultimately we scaled out with cloud and more automation in our network management through the 2010s. But now here we are in the 2020s, and we're seeing more and more need for and initial implementations of ML and AI on top of everything that's happened before. And so this is an exciting time. This is a new era of networking, and we think it is going to help, and I'll explain why I say that. But first, just a few more proof points from Enterprise Strategy Group. Back in 2020, they were already predicting that there was a need for more automated, self-optimized healing network environments. Why? Because you always were depending, kind of hoping that somebody was going to be like expressing their individual heroism to solve the critical issue that was causing an outage, or causing the chancellor to tweet out that the campus Wi-Fi network sucks. And like, what are we going to do about that? And so we can't rely on that going forward as we have more networks and more complicated networks and the use of them. And so by 2022, the prediction is that more network intelligence via AI and ML technologies were going to be needed to provide the tools to help you manage increasingly distributed and complex environments more efficiently. And that's exactly where things have come. But it's to address these broad sets of challenges, which we've kind of broken into 3 buckets, right? So for many campuses, if you're a small, medium campus, you're a community college, et cetera, or you have lean IT, you really are struggling with network visibility and control to make all of this work. That's a challenge that I hear almost every time I have a conversation with a customer. And then second, how do I know that the services, if I'm in information services, how do I know those services are going to work when they're needed, especially at scale? And we'll talk about what some of those services are. And then finally, from an administrative or a CTO role or CIO role, how do I know that my networks are fit for future for digital learning as we see this drive toward more online learning, as we see the drive to more hybrid flex pedagogy, where I'm bringing in video cameras and microphones, and I'm doing little broadcast studios, kind of like we're doing right now, in a classroom, right, with flat screens so people can participate remotely, or I've got overflow classrooms, and I've got the, in every room is becoming a little broadcast studio, right? The demand on the network is growing to create these more student-centric services. How do I know that as I scale this out across my campus, that my network is going to keep up with it? These are sort of the common challenges that we see. Now, I think analytics has a role to play in answering this. And so what I want to do is get real about this and not just talk pie in the sky, but actual analytics packages that we can look at and see examples of right now. So Ruckus Analytics is one of those. It's an AI-driven cloud service that's going to give you wired and wireless assurance. It's going to increase IT efficiency. But why? To provide reliable connectivity for digital learning. And look, that's why I'm here. That's why ByteSpeed is here. We want to help you provide reliable connectivity for digital learning in your campus. This is just a new tool, as I said, a new era of networking that you should be aware of and see what it can do to help. All right, but what do I mean by autonomous networks and moving to this new era? So remediation is sort of the new thing, right? So building on what's happened in the past, we had to detect issues as they come up, right? So how do I detect it? Somebody reports an issue. I found it running my own tests. I have an autonomous network that's finding it for me. But traditionally, it's somebody struggling. There's an outage, or the network is slow, or I'm getting disconnects. And so I report an issue, and it comes into my my network tool as a bug or a complaint to the help desk. I then have to look at those issues and prioritize them. How do I know which ones are the most important? Which ones are the most impactful? Which ones are critical services that are being disrupted, like teaching and learning, as opposed to playing games, et cetera. And then what's the root cause? And by the way, prioritization, you also want to look at how many users impacted, what devices were impacted. Is there any way to work around it or not, right? So that all goes into it. And then what's the root cause of that issue, and how do I detect that, right? Can I find out using the tools available to me? Am I looking through, parsing through logs? Am I running remote packet capture, or do I have to go on site to do a packet capture? Do I need to talk to the users? Do I need to gather their devices? Do I need to visit that site? Do I need to do a site survey and do a spectrum analysis? So there's so many issues that I could do, or so many approaches that I could take to figure out that root cause. Ultimately, you want to recommend a fix, or come up with an idea for a fix, which may be something as straightforward as a configuration change on your network, right? But what configuration change? What's the most impactful to that issue that has the least, impact on everyone else and the rest of the network, right? So do no harm. So do I know what the trade-offs are? If I make a configuration change to address a root cause of a P1 issue, how do I know that I'm not going to inadvertently impact my KPIs for the rest of my campus community? So that's part of the right set of recommendations. And then ultimately, do I do that thing, right? Do I make that config change to address the root cause of my high priority issue that I detected earlier, right? That's the remediation. And we get to the point where if we're detecting all of this and coming up with a set of recommendations, then we can start remediating those issues, because I know what the root cause is. I know it won't have a negative impact. And so just go ahead and do that. That's the auto healing potential. So let me give you a little bit more granular on what that looks like before, after, from a workflow perspective, right? So let's say you come in on a Monday morning and you haven't had a chance to look at your network over the weekend. Good for you. That's part of the IT work-life balance, right? But here it is Monday morning, and you're looking, and maybe there's 10 issues that have come in and hit your dashboard. Oftentimes, we know it can be common to just say, look, okay, here's 10. It's just like reading your email. Do you look for the most important ones first, or you just kind of read them in the order you got them? And a lot of people tend to be in the habit of looking at the issues in the order that you got them. And so you're going to respond that way, and you're going to start looking at those issues and start digging into them and doing your root cause, right? Like I said, you may have the ability to find it right within your tools, your network management tools, because they are more sophisticated today than ever. But in some cases, you are going to have to start parsing through logs. You may have to do some packet capture. You may have to call some impacted users, or gather their devices, or visit the site for yourself, et cetera. And that can take, minutes, hours, a day, multiple days, depends on how insidious that issue is. When you get a bad cable, that's sort of like a really frustrating one that can take a long time to figure out. So once you kind of think you understand the root cause of that issue, you go ahead and make a network setting change based on your intuition, based on input that you may have from others, and hope that it makes a positive change. But you don't really know if it's going to have a negative impact, right? So you got to monitor it, hope that it works, and then maybe tinker with your network settings after that. Well, this is a pretty manual intensive workflow, which is causing a lot of people to feel like, look, this is not a good work-life balance. I'm getting burnt out going through all of this effort over and over and over again, issue by issue, day after day. So let's take a look at what this new approach with AI ML analytics looks like. In this case, over the weekend, the system has been self-testing constantly, and machine learning-driven incident and anomaly detection has surfaced some potential issues before anyone has actually reported them, before users noticed and complained. It's now going to use AI-driven prioritization to say, of those issues, here are the ones that we think are P1, P2, P3, P4, based on some criteria that we've helped define, so you can help address the most urgent issues first. again, it's going to look at maybe the size of the area impacted, the number of users potentially impacted on what devices, what applications, and are there any simple workarounds or not, right? And that's how it's going to come up with a recommendation on prioritization. And so triage the issues for you. Then ML-driven set of recommendations for, what are the root causes? What are the root causes and what might be the recommendations to address them? So now I've surfaced the issues, I prioritize the issues, and I'm going to put forth using machine learning what I think the root causes are and set of recommendations in plain English in front of you. In plain English, because it's really important that anyone can understand what the challenges are. It can be a new hire, it could be a junior person, it can be, I'm going to take this screenshot, I'm going to share it with my purchasing department that says, I need to upgrade this network equipment because look, this is what the challenge is, right? I've heard that feedback as well. So it's very handy to help you justify getting funding for your IT projects when you can share in plain English. This is what's causing the students to complain, let's fix it. All right, now again, if the recommendation is to change the configuration, that's fine, but now you also need configuration change tools as well that says, if you make this config change, let's monitor it, what the impact is after you make that config change and allow you to roll it back if necessary. So if there's new issues that are up, you kind of know it was related to that config change. Or if your SLAs have been impacted, you know it's related to that config change and you can roll it back if you need to. So in the end, AI recommendations is allowing the system to analyze the issues and make recommendations to improve network performance. Things that were taking you a day or multiple days could literally be done in minutes to an hour. And what does that mean? It means it's restoring some work-life balance. It's addressing this issue of burnout. It's allowing you to solve problems, which is what you enjoy doing in IT, and not chasing things down all the time and spending all your time doing that. And so, be home in time for dinner, see your kids' soccer game, enjoy your weekend, right? Because the network is helping you, right? Not replacing you, but it's helping you to do your job more efficiently and effectively. And it's not just about proactive network health, although that's a huge piece of it, right? If you've lost staff or are losing staff to higher salaries in private enterprise, or they're retiring or they're just feeling burned out, then your remaining staff needs something to help them be more productive, and tools like this that offer these amount of insights, right? Dashboards with clear guidance to help you resolve issues in plain English so that a junior person or a new hire can do it. It's incredibly powerful. But it's also going to deliver service readiness. So things like, how do I know if I have online testing that's coming up next week, how do I know that the network is ready for that? I can self-test to make sure that there aren't any major issues in the network and I feel like I'm ready for that online testing. If I'm doing esports, wow, like 70% of schools, colleges, universities are moving more and more into setting up esports clubs, esports tournaments, competitions, new courses and degree programs. It's a very exciting area, but it's even more demanding on your network because it's not just about coverage capacity, it's about latency sensitive applications as well, right? Video calls, Zoom calls, et cetera. So simulating connections, running loop packet tests to detect faults in advance is incredibly helpful for service readiness. And then finally, equity and performance SLAs. How do you know that all the students on your campus and between your campus sites are getting equitable access to resources and network performance? This is more and more important. Equity is showing up on many people's radar. It's showing up on their strategic plans to, again, make sure you're treating all of your campus community fairly. And SLAs and network access has a role to play in that. And so being able to compare performance between buildings, between sites, and knowing that everyone has the access they need for successful digital learning is becoming more and more important. All right, so great to have an SLA, but what does that mean? And why are things necessarily out of SLA? So for example, here's an SLA from RUCKUS Analytics. It's got 6 different parameters it's looking at. And if I just poke at connection success, looks pretty good, 96%. But what's going on with that other 4%? If I take a look at this, it's going to show me that, okay, out of the 2,911 connection attempts, there are 105 failed connections. But where, right? Well, here it's telling me out of the connection protocol, I'm seeing 75% or 79 failures at EAP level protocol. So EAP failures is my #1 challenge in this venue at this time. It's also going to tell me where, so which venue am I seeing those failures, and within that venue, which users and which devices are being impacted. Well, that's a lot more insight than just saying 94%, or sorry, 96% connection success. So that's the kind of level of detail that you can get to with an analytics engine. And just as a proof point, one of our partners in Europe, managed service provider YFirst, they were struggling to keep their SLAs for their end users when they were getting network-related complaints. They spent 6-person weeks trying to solve a very troubling issue that was presenting itself as a Wi-Fi issue, but to no avail. And when this tool became available to them, within minutes of turning on Ruckus Analytics, it analyzed the network, looked at what the users were seeing, and said, no, it's not a Wi-Fi network issue. It's a different hardware element that is the source of the problem. They were able to fix it quickly and said, wow, like this is going to make us so much more dramatically more efficient than we were before. 6-man weeks replaced with minutes, right? That's the impact of this, right? So that's why I want to share this with you, to dramatically improve your work-life balance, because you shouldn't have to spend 6-man weeks chasing something down that can be detected in minutes. Now, if you made a config change to something, what did the impact have? And here is an example where a configuration change is being made here on March 11th. You can see, but come March 12th, sort of out of bounds for my SLAs, it's negatively impacting my user experience. And so with a click, you can see my time to connect has gone from under 2 seconds to over 20 seconds. My EAP success went from 62% to 47%. Radius success dropped from 94% to 60%. I need to roll this config change back before everybody blows up at me and starts complaining about this. So that's what we mean by, you know, do no harm, and know if you're doing no harm, and know that you need to make a different change. I mentioned service validation. This is testing that's going on in the background against your different services to make sure everything's okay. You know, it's testing EAP, Radius, DHCP, DNS, ping, traceroute, speed test, you name it. And when there's an issue, you can double click into it to find out what's going on these automated self-tests. Like I mentioned, online testing prep, esports. You have a tournament coming up. How do I know that the network is going to handle it? Zoom calls, Zoom huddle rooms are very popular these days for collaborative work groups, for research, connecting from users from different campus sites that can collaborate on projects. So you want to make sure that your Zoom is running. And we have service validation just on Zoom. So there's a new Zoom video call quality of experience, where it's going to look at things like jitter, latency, packet loss, video frame rate, et cetera, and tell you if your quality is good or not. So that's just one example of service validation. All right, so that was a quick flyover of sort of what the challenges are and how analytics can give some practical benefit to help restore some of your time and some of your effort back to IT. But I want to go a little bit deeper into this notion of purpose-driven enterprise networks and what we're doing at Ruckus. We're doubling down here. AI ML powered purpose-driven networks is really what we're viewing as our future and what we think is going to be most impactful for you, certainly within higher ed, which is some of the most challenging environments to operate in. And so 4 pillars of our technology vision are centered around this. Our architecture, our thought leadership, simplifying your customer journey, and then performance leadership. At Ruckus, we're known for our Wi-Fi performance leadership with things like Beamflex and Channelfly, and this really helps us take it beyond to the next level. And that's why I'm kind of geeking out and excited by this. So what this translates to is different elements of our hardware platform will now have an element of AI-driven software tied to it to take that next step. So whether it's Wi-Fi, switches, 5G, et cetera, you can expect to see that coming in the near future from us. But let's start with what we have now. We already have Wi-Fi machine learning with Beamflex. That's exactly what it does. But now we're adding AI-driven radio resource management on top. So I want to talk a little bit about what that means. So basically, AI-driven cloud radio resource management, or RRM, it's an algorithm. It's running in the cloud. It's going to manage co-channel interference for you, looking at radio resources and transmission characteristics. It's going to look at the AP deployment that already exists that you've made, and it's going to apply this algorithm to learn from it and say, how can I optimize that configuration for things like AP capacity or performance? It's a very compute-intensive algorithm. It's running in the cloud. So that's what we're talking about. So the benefit of doing something like this is going to allow the network to optimize what channel you select and what channel width you deploy with. And the benefits of this are several. potentially zero co-channel interference whenever the laws of physics allow. Kind of like that phrase, reminds you of Scotty from Star Trek. But it can't change the laws of physics, but I can adapt to them. And that's what's going on here. The ultimate benefit of this is lower airtime utilization, which is going to translate into higher AP capacity and client throughput. And that's the part we care about because it's going to improve the user experience. And also important, I want to point out, is that your APs are going to operate at maximum capability, even when they're deployed in proximity, such as lecture theater, auditorium, graduation, classrooms in academic buildings where you're deploying one AP per classroom. These are all areas where traditionally the APs get near each other, you start getting neighboring interference. And one of the things as vendors tend to do is say, oh, are they interfering with each other? Well, here's what you could do. You could disable the radios. You can lower the power setting. You can basically reduce the AP from what you paid for to what will work in your deployment. Well, that's not a good answer. Nobody wants to be told that, you basically overbought or overpaid and you need to turn it down to make it work. What this does is say, I'm going to restore the full capability, the maximum capability of those APs that you paid for and give you the best possible performance by just being a little smarter about how you deploy it. So let's take a look at what this is. Let's visualize this. So this is an example in a middle school. And what we're looking at, these circles are access points. And the diameter of the access points, the diameter of the circle translates to the channel width that's deployed. In this case, 40 megahertz channel width. And in this case, what we're seeing is that the average number of neighbors per AP is 7, which is kind of too high, right? So practically speaking, this is roughly a 1 AP per classroom deployment. And what you're seeing on the left is all the circles are the same diameter. They're all operating on the same channel width. And the color tells you what channel they're operating or frequency they're operating in. And so if you see a number of APs in proximity of the same color, then potentially those are their neighbors that are interfering with each other. And that'll show up with these bands in between them. And so you see, for example, on the left side toward the bottom, you see 3 blue circles with green bands in between. So those APs are interfering with each other. And anywhere you see the bands, it's between same color APs that are within physical proximity. On the right is after the algorithm is applied. So AI-driven cloud radio resource management has been applied. And now they're still running on the same channel width, right? The circles are the same diameter, but we reallocated the channel selection. And so their frequencies are different. And we went from 9, almost 10% co-channel interference ratio to 0, literally to 0. This is where I geek out because I always thought co-channel interference is just the trade-off we make. It's the deal with the devil we make to deploy. You need higher capacity and coverage. Okay, more APs. Yes, it's going to create this issue because it's a contention-based access network. But here's a way to deploy it smarter to avoid that contention. And that is what is new and exciting about this. Let's give a more interesting application beyond this. Now, this one was done, I believe, in another site with more access points, like over 100 access points. The red lines, again, are representing co-channel interference, and it's between circles of the same color that are in proximity. In this case, we're running 5 gig, 40 megahertz width, and theoretically, the best you could hope for in this model is a co-channel interference ratio of 8% in 5 gig band, 11% in 2.4 gig band. So what could we do if we applied AI-driven radio resource management to this scenario? Way more complicated, more APs going on here. And what it came up with was both moving access points to different channels, channel selection, but also change the channel width. And so now you're starting to see bigger circles and smaller circles and different color circles, right? So what it's saying is this algorithm now changed 6 of the APs onto 80 megahertz channel width. And so those are the fatter circles. And it moved down 20 APs to 20 megahertz channel width. Those are the smaller circles. And then it reallocated the channels of, I believe, all the APs and got to 0 co-channel interference. Now, you look at something like this, where you've got 100 access points deployed across an area in proximity of each other. And to say, I'm going to run different channel widths, different channel selections, this is a hard problem, computationally expensive problem to solve. And can't be predicted, but can be verified. That makes it an NP hard problem. And Ruckus has a patent pending to solve this issue for you. So what is the benefit? In that particular scenario, an 18% boost in AP capacity. Why? Because again, we're more efficient with our airtime. We're removing the contention out of this. And what we're seeing is an 18% boost. You can see on the left, the legacy network performance on average and by peak. And then on the right, the cloud radio resource management. Again, this is over a period of, I think, like a week for each. And you can see the level has raised as well as the peaks have raised. And so we boosted our AP capacity by 18%. So some pretty cool practical aspects of this. All right, so I led off by saying that these networks are now too complex for normal humans to manage effectively. But the good news is, I mean, as I'm trying to show you, with the help of AI and analytics and the power of the cloud, it can provide some additional guidance to us, both for network management, as I talked about with the analytics engine and doing, root cause analysis and recommendations and config change analysis, and now to radio resource management and how we deploy things to reduce co-channel interference and get the benefit of the full capability of our access points. I think we're getting to this next era of networking where AI/ML is giving you the tools to kind of get back some control and kind of restore some work-life balance, because it's really hard otherwise. I'm throwing this in here as an overview so that you'll have it. You can screenshot it or get these slides from Aaron. But a lot of benefits to analytics. Like I said, in the upper right, the insights and recommendations are in plain English, makes it easy for everyone, even the folks who provide budget, to understand what you're doing and what you need to do. Simple query, I didn't even mention this, but there's a tool called Melissa. It's a virtual network assistant. Think Siri for your network. So voice query into your network and stats, very cool, makes it easy for anyone to quickly look at what's going on in your network. Extend the useful life of your network. And I like this one too, right? Like, we've all been challenged over the last several years to get the specific device SKU that we want and the lead time we want. I believe me, I get it. I hear this all the time. But what if the network could baseline its performance and say, I know we need network infrastructure within these multi-gig classrooms because they don't have sufficient capacity and coverage, but I've got these APs over here that are being underutilized. And if I could move those over to these high need areas and reallocate some lesser capable APs into those low usage areas, then maybe I could get by for a few more months or another quarter or two until that new equipment arrives, right? So load balancing extends the useful life of your network through analysis of your network and baselining. And then tuning up network performance, having the tool analyze your entire network deployment and saying, here's opportunities where you've got multi-gig APs plugged into giggy ports and you're not getting the benefit of that AP. That's a network wireless tune-up, right? Maybe you don't have the full PoE, and maybe I need PoE plus, and I'm only applying PoE, and I'm not getting the full capability of my tool. Again, very hard to keep track of over time as you make changes, but the network can run a quick run, baseline it, and point all those out. They show up as like P3 issues, but what you're really doing is a network performance tune-up. So a lot of benefits, side benefits to an analytics engine is going to make your life easier. All right, I'll just throw that in there as well. And I'll just point out that this is starting to get traction. We got noticed at FETC. We're a finalist for Top EdTech Product of the Year, so I was happy to see that. And I do hope you'll take advantage of the opportunity to talk to ByteSpeed. And at this point, Aaron, I'm going to turn it over to you to answer any questions. Thank you.
Thanks, Rich. That was some great information, very exciting stuff. So now for some next steps, if you guys are interested in learning more, you can reach us, at ByteSpeed. We can help set up, proof of concepts, online demos. We can help you review your existing, infrastructure. The easiest way to get a hold of us, we have a 1-800 number. If you call 877-553-0777, that's just our main line. You can email us at sales@bytespeed.com. That'll reach our sales group. We'll get you to the right person to get you what you need. If you'd like, to set up a review of your network, you can just go to bytespeed.com/ruckus. We can fill out some information, kind of get you started there. And then, if anybody would like a copy of Rich's presentation, feel free to raise your hand in the chat. I'll send you a copy of that.
Please do.
Yeah. We'll share the information with you. And then, Otherwise, does anybody have any questions or anything? Oh, I do see a couple that have popped up. Let me take a
Okay,
look
great.
here. So I do have one here that says she's asking if Ruckus Analytics hardware slash software is it like agnostic or required to utilize only Ruckus hardware slash software?
That's a great question. I got the same question when I presented this at Bet UK a few weeks ago. And the short answer is no, it's not agnostic. It's designed to run on Ruckus infrastructure. What I could say though is if you want to try it, I think it's worth having a conversation to say, is there a challenging area on campus, or is there an opportunity within your IT admin building or somewhere where you could try a handful of access points or a switch and test it out, right? Or put in a small pilot and say, I'm going to put it in for 60 days and play with the interface and talk to us and see what it can do. Because you do want to baseline and get some data, right? You're not going to just turn it on and put 2 laptops on it on a desk, and within an hour you're going to see all the benefits. Like, that's not exactly how it works. You will get to play with the interfaces and the screens and whatnot, but I think it's worth having a conversation of how to get it into your hands to try it.
Sure. And I got one more here so far. This one, he's asking if the configuration changes occur automatically, he says, or is human intervention required for these optimizations?
Human intervention, right? Right now, these are being presented as suggestions on how to remediate, and then you can go ahead and take that next step. It's not automatic today. I know that is an option for some, and that is a path that I think a lot of people are looking at doing. Personally, I like the idea of giving IT more control and saying, this is what I recommend, but you click the button. And then we also have our back to say, I know who clicked the button. Right. And so there's some accountability and control when you do that. So that's a great question. Yeah.
Perfect. Well, does anybody else have any other questions? Otherwise, I think that's all I've got.
And my email is there, and I'm happy to take questions offline, but please do reach out to our friends at ByteSpeed. They're well certified and knowledgeable and have many deployments with our Ruckus gear and can help you, I'm sure. Again, I would be thinking about maybe the small POC or trial that you might want to get started just to get your hands on it. I think you'll really appreciate the insights that it starts to deliver and how easy it is to use. I can't stress how straightforward that is and how easy it is. I have a use case where there was an IT fellow named TJ in Novato. He was part of the finance IT team who helped select the equipment that was being used. And then it was deployed and Ruckus was deployed. But their IT director ended up resigning during COVID, part of the Great Resignation. And, school started reopen and the students are coming back and they didn't have an IT director. And they said, TJ, you're the new IT director. And he said, wait, I'm the finance guy. I'm not a network engineer. And they're like, yeah, I get it, but you'll be able to do it. We'll hold your hand. This software will kind of show you in plain English how it works. Within 6 months, he was running the entire network with thousands of students. And a year later, I'm with him at a conference as he's presenting with live demo of how he manages his school network. That's what I mean about the power of AI/ML enabled networks. So I do hope you'll take advantage of the opportunity with ByteSpeed and give it a try.
Yeah, totally. I don't see any other questions popping up, so I think maybe we could just probably go ahead and close her down. Just wanted to say thank you to everybody for joining us today. We will be posting this video on our YouTube channel, so if you need a link to it or something, I'll be sending those out as well. Otherwise, if there are no further questions, I think we're good.
All right. Thank you, Aaron. Thank you for having me, and thanks everyone